In this video, I'll be explaining you what is sets. So to explain set, let me to consider an example. Suppose that we have here a bus. We have here a bus, and in this bus we know that all the cricket team is going to be here. All the cricketers are going to be in this bus, and then we have another one bus in which we need to send all the footballers. So here in this bus I need all the footballers. Now I have two players with me. One is Virat Kohli and another is player Messi. So you know where Virat Kohli will go. Virat Kohli will go in the cricketer bus because he is a cricketer, and Messi will go in the other bus. So obviously now when I say, we'll understand now this as a set. So you know as a person that if you need something to search in this bus, you know that in this bus I'm always going to find cricketer. You cannot find the footballer in this particular bus. If you need to search the footballer, you will go and search into this box. So basically set is a collection of ordered thing. So we can say set is a collection of objects. It is a collection of objects, but well defined. When I say well defined means I know what I'm going to search into the first bus and what I'm going to search in the second bus. So I know I'm only going to find a footballer. There is no point in finding any athlete into this or any cricketer into this. So let us write a proper definition. So set is collection of well defined objects. So when I say well defined object, I know what I'm searching or I know what I'm putting in a particular set. Say for example, you have a box. Now you have to again put into this box all the natural numbers. Let us see what are the natural numbers. We know the natural numbers are those that are 1, 2, 3, 4 and so on. These are the natural number. Even 0 is not a natural number. 0 is a whole number, or I can say 0 is an integer or 0 is a real number. Now suppose I want to say that you have -2, and I have already told you that in this box you want to only put the natural numbers. So what are the possibility that you will put into this box? Either you may put 2, you may put 3, you may put 6, or you may put 1, but you will never put this -2 in the box because you have already said that in this box I am only going to consider the natural numbers. Now suppose you define that I have a box in which you can put the integers. Now you have said that you want to put integers into the box. So this means you want to now put something like -2, -6, 4, 5, 0, all are integers. You will not put any number of the form 2 by 3. 2 by 3 is a rational number, and because you have said that in this box I only want to put integers, so 2 by 3 will not go into this box. So set is basically a collection of well-defined object where you know what you have with you, and this is what it defined the set. So in this set, once we know what is the rule, we know what are the objects that with which we can work upon. So now let us consider some more statement here to see the set. First statement says collection of cities in India. Is this a set? Yes, this is a set because we know there are finite number of cities in India and you can make a list of that. So you know that this is a set. Collection of beautiful objects. Now there is no definition of beautiful object. Something may be pleasing me, may not be pleasing you. Something which I find it is very beautiful, somebody may not find it to be beautiful. So it is a very vague statement. So here we'll say this is not a set. We cannot well define. Then next it says collection of good actors. Again, what is the definition of being good? I may say something good, somebody may not like it to be good. So collection of good actors. No, this is not a set. Collection of even integers. Now this is a set. Let us see why this is a set. Collection of even integers. We all know what are even integers. 0, 2, 4, so on, and here we got -2, -4 and so on. These all are even integers. So I know what is, if somebody give me an integer, say for example somebody give me 7, I know this is not an even integer. So I know, or somebody give me -8, yes, this is an even integer. So you know, once you know answer to your question and you can well definedly you can write down something about that, then it is a set. Collection of prime numbers. This is also a set because we can say what are the prime numbers? 2, 3, 5, 7 and so on. The numbers which are divisible by 1 and itself. The only prime divisor. So we can say if I say P is a prime, then its only positive divisors of P are 1 and p itself, then we say that this number p is a prime. So we can continue the list, and we know if you give me a number, suppose if I give you a number 27, so you know that 27 has other divisors also. It can be divisible by 3 also, it is divisible by 9 also, so it is not a prime number. So this is a collection of the prime number is a set. Now as we know a little bit now something about sets, so consider a set here, something of natural numbers. So I am considering a set of natural numbers. Now considering this set of natural number, if I want to know what are these here in these position, these are numbers, but these are also called the elements of the set. Elements are the objects in the set. So they may be number or they may be any. For example, now you consider a set where I say this is English vowel. So this English vowel will be A, E, I, O, U. So A is an element in the set. This is an element in the set. E is also an element, I is also an element, and O is also an element, and U is also an element. So these are elements of the set. And to write the element, we use the notation belong. So let us write down here. We use, say for example, I want to show that E is an element of the set capital A. So let us call this as a set capital A. So we will use the notation E belongs to capital A. This notation I am using it as belongs to. Belongs to means it is in the set A. Or I can say I belongs to the set A. If now you can see here F is not a vowel. I have considered here capital A as a set of vowels. So F is not a vowel, so I will say F does not belong to the set A. This notation is does not belong to. You have to just cross this line. You have to just cross this symbol by a single line. Does not belong to. This means this element F is not a part of the set A. Now let us understand how to describe a specific set, how to write down about a set. So there are two forms. The first form is the roster or the tabular form, and in this case roster form or the tabular form where we can simply write the data in the set, and the second is set builder form. Now in this set builder form we must need to mention certain conditions. So let us look at the first case first, and in this tabular form I am going to show the set with these braces or the curly brackets. To explain this, let me to consider an example. Let's consider an example set of all factors of 24. So we need to make a set where I am going to consider factors of 24. What are the factors of 24? And let us show this by a set also. To show it by a set, let's write down the set as S is the name of the set, is the name of a box or a bus or anything that you can imagine, but you know what is there in that set. So because I want to find down the factor for 24, so let's divide the positive factors of 24. Here I am considering the positive factors, not the negative one. So we will start from 1 divides 24, yes, 2 divide 24, 3 divide 24, 4 divide 24, 6, 8, 12 and 24. So that's it. These are all the factors of 24. So we can split that 24, keep on splitting that into smaller factor. And you know that all these numbers are dividing 24, so they act as a factor of 24. Let us take one more example. I want to now consider set of all letters in the word mathematics. So let's see. Let's write one letter once only. M, A is coming. You can write on small letter or you can write capital letters. It hardly matter. T comes, H comes, E comes, M is repeating, so leave it. A is repeating, leave it. T we have already written. I is not written, so write I. Then we can write C and we can write S. So this is the letters which are repeating in the word mathematics. In the set builder form, I want to write down the set with certain conditions. So that is why it is written builder form. So you need to understand the set with the condition. For example, let us take an example to understand this situation. We need to write down a set A where I am taking A as 1, 2, 3, 4, 5, 6, 7 and I am saying write A. We can see from these curly bracket that this is a set, but I want to write this into the set builder form. In this set I only have some natural number which are starting from 1 and they are finishing out in 7. So I want to now construct a set A again when I'll say that A consists of an element X. X belongs to natural number. You can see that this is the notation for belongs to. But there is a condition on X. It is a natural number, so the least possibility for N is already 1. We can see the natural numbers start from 1, 2 onwards only. So but when I said X is a natural number, but the upper bound on n is mentioned. Upper bound means I already have what is a final number with me in the set. So I can say x is strictly less than 8, or I could have also written this set as x such that x belongs to n and x is less than or equal to 7. Now if I put it as less than or equal to, that means 7 is included. This symbol stands for less than equal to, so I will include the 7. Here it is strictly less than, so I will not include 7. So both are the set builder notation for the given set. Now consider one more example. I want to write the set C this in the set builder form, but let's see what is the condition on C. This is 2. I can write 4 as I need to find certain rule that define all of them. You can look at that 2 is a multiple, 4 is a multiple of 2, 2 into 2, 4. Then you can again multiply by 1 more 2, you will get 8. Again multiply 1 more 2, you will get 16 and so on. So this means I can multiply or I can take this into the power. 2 square is 4, 2 cube is 8, 2 to the power 4 is 16 and 2 to the power 4, 2 to the power 2 is 4 and 2 to the power 5 is 32. So you can see now you got certain rule. Everywhere you see the base is 2 and in the power you have 1 to 5. So I can write down this is set C is x such that x is the value is. What is the value for x always? You can see each element is something 2 to the power some n. But what is this value of n? N moves from 1 to 5. You can say n belongs to natural number. But there is a range on n. Least value for n is 1 and the maximum value it can take 5. So this is the set builder notation for the given set. So we need to understand now the set from the conditions. The earlier that is given to me, this is roster or tabular form where I know what is exactly value of it. But in this other form, I have this as set builder form. Set builder allow us to write the data in a very concise manner. Take one more example, and in this example again I want to write down this set E in the set builder form. So let us look at E very carefully. Again in the E we have certain element x. What is the condition on x? Because I want to write this into set builder form. It is already given in the tabular form. Here we can look at that. This is 1 by 2, this is 2 by 3, 3 by 4, 4 by 5, 5 by 6. We can see every time the denominator of previous term is the numerator of the next term. And the last term is 8 by 9. So we can start it from the value for x is something n upon n plus 1. Okay. Every time x is something n upon n plus 1. If n is in the numerator, then the next term is in the denominator. What is the first term that you want to have? The value for n is 1. So we will start from n. What is the last value? Because we want 9 here in the numerator. Look at it in the last term. Last term in the numerator we have 8. So if in the numerator we have 8, in the denominator we will automatically have 8 plus 1 by this formula. Or we will say 8 by 9. So we will get the last term. So that means the last value for n is 8. So this is the set builder form, and you can here mention that n belongs to natural number. It is important to mention n belongs to natural number because there are many infinite rational, irrational number lying between 1 to 8 also. If we do not mention this condition in the set builder, then somebody may choose take n is equal to 2.5. Okay, this lies between 1 to 8, but this value is not allowed. We only want to work with the natural numbers. So put this condition on n also, that n belong to natural number.